alternative equilibrium equations. In addition of the equilibrium equation, which was in two-dimensional system, there are two other ways to express the general conditions for the equilibrium of force in two dimensions. The first way is illustrated here. One, consider this picture. This figure, part A and B for the body shown in this picture. If the momentum on A equals to 0, then the resultant, if it still exists, cannot be coupled but must be a force R passing through A. If now the equation sigma fx holds, where the x direction is arbitrary, it follows from figure 6b, this picture, that the resultant force R, if it still exists, not only must pass through A but also must be perpendicular to the x direction as shown. Now if the sigma mb, where B is any point such that the line AB is not perpendicular to the x direction, we see that R must be 0 and thus the body is in equilibrium. Therefore, an alternative set of equilibrium equations are these three equations. An equation of forces MA and also sigma MB equals to 0. Where the 2 points A and B must not lie on the line perpendicular to the x direction. The next alternative, a third formulation of the equilibrium condition may be made for a coplanar force system. This is illustrated in the picture here. Coplanar figure 36C and 36D. A third formulation of the equilibrium conditions may be made for a coplanar force system. This is illustrated in figure part C and part D. Again, if the momentum around A this point equals to 0 for any body such that shown, the resultant, if any, must be a force R through A. In addition, if also the momentum around B, this point, as shown in the picture. Such a force cannot exist. However, if sigma the momentum around C is 0, where C is not collinear with A and B. Thus, we may write the equation of equilibrium in three relations. Where A, B, and C are any 3 points not on the same straight line. When equilibrium equations are written which are not independent, redundant information is obtained and a correct solution of the equation will yield 0 equals to 0. For example, for a general problem in 2 dimensions with 3 unknowns, 3 moments equation written about 3 points which lie on the same straight line are not independent. Such equation will contain duplicated information and solution of 2 of them can at best determine 2 of the unknowns, with the third equation merely verify the identified 0 equals to 0 and is ambiguous. Constraint and statistical determinacy is the next section.